Good morning, everybody. Welcome to NTI day 14. It's a little bit crazy that this is happening the way it is, but that's just the reality that we live in. I'm gonna close this door. Get out of here, puppy. Okay. I forgot to print off the notes to copy along in the video along with you, but pull the notes open on the Google Classroom so you can follow along, because you'll need to fill in the blanks as we go through them. So at the top of the notes, on the top of day 14, you have the notes section, and in the notes section you got 4 definitions. One, maybe two of these you've seen before. Let's just go through them. So first, we're going to define arc again, and an arc is just a portion of the circumference of the circle. We've been doing that for a while, so hopefully you're okay with this. So you got a circle, an arc, and arc is just a portion of that. So like if you took a piece of that circle and pulled it out, that would be an arc. Arc length is the distance along the arc. So up to this point, we've been finding the measure of arcs in degrees, right? So if you have a central angle, like if you have a central angle, so there's a center, if you have some piece going like this, what we've been doing, we've been saying this arc is the measure of the central angle in degrees. Arc length is something a little bit different. We're going to actually, it's like if this is a piece of yarn and you just made a circle out of it, we're going to measure the distance either in inches or in centimeters or whatever of just that sliver of arc there of yarn. So arc length, we're going to actually be measuring the distance of the arc. And that's going to be in inches or centimeters or feet or whatever. It's not going to be in degrees, okay? Arc length is just a little bit different. We're measuring the length of the arc, okay? A sector. A sector is a part of the circle that is enclosed by 2 radii, and a radii is just the plural version of radius, so it's 2 radiuses. Enclosed by 2 radii of a circle and their intercepted arc. So all that means is you got this picture, there's 1 radius, so this is the center of my circle. That means that's a radius, that means this is a radius. So we have our 2 radii, and they form an angle. So it's a part of the circle enclosed by 2 radii of a circle and their intercepted arc, just meaning they intercept the arc at this point and at this point. So this is the formal definition. You just think of it as a slice of pizza. So a slice of pizza is a sector. This whole space inside here is a sector of the circle. And then the circumference, we've talked about this. The circumference is just the distance around the edge of the circle. So you can sort of think of it as like the perimeter of a circle. The circumference is just that. So if I started here, so if this was my circle of yarn, and I started here and I just stretched this circle out to where it was a flat line, that would be the circumference of the circle, is that distance. Okay. So for all I'm going to do for this video is we did the definitions. I'm going to go over a few important formulas, and then I'll close this video out, and then we'll do some examples. So for this lesson, the important formulas that we need to be comfortable with, and I might actually, here, we'll start with the circumference. The circumference of a circle. So if you have a circle and you're wanting to measure what is the distance, if I start here, what's the distance if I make 1 lap around the circle and go back? What's that distance? Well, that's calculated as 2 pi, so that's 2 times 3.14 times the radius. Something else I want to say for this week, we're going to be dealing with pi a lot, and we're not going to basically, like if you have 2 pi, we're not going to do 2 times 3.14. We're just going to leave it at 2 pi. Pi is a very important number involving circles, and it's just easier, and mathematicians just prefer leave the pi in there. Don't round this to 3.14. We're just going to leave it pi, and then I'll show you what that's going to look like. So the circumference, to calculate the circumference of the circle, it's going to be 2 pi times the radius. So if you got a circle here just like that, or actually we can just use this one. So if this radius was 4, this was 4 inches, the circumference would be 2 pi times 4 inches. 2 pi times 4 is just going to, so 2 times 4 is 8 pi. So the circumference would be called 8 pi if this radius was 4. 2 pi times the radius. You want to leave the pi just as it is, and then we'll multiply 2 times whatever the radius is. That's the circumference of a circle. What is arc length? So how would we find the distance? So we can do circumference. How would you find the distance of just this arc right here? Just a piece of it. Well, we have this. This is a Greek symbol called theta. It's like, I mean, it looks kind of like a pokeball or something. It's like a circle with a line going through the middle. This is just basically what we in math. This theta. This is what we use to represent an unknown, or it's what we use to represent angles or degrees. Is this in the notes, or if you're doing this online, you can just you can put X there if you want, or if you would like to impress me, you can find the theta. You can go to insert symbol, and then you'll find theta under Greek symbols. But if you just want to put X for this on your notes, that's fine with me. You just put X for that. But I'm going to say theta for the notes. So theta is this Greek letter. It's a pokeball symbol. To calculate the arc length, you're going to do theta over 360, where theta is my central angle. So let's just pretend this is, well, here, hold on. Let me before we do an example. So theta over 360 times my circumference. The circumference is 2 pi times the radius. 2 pi times the radius. 2 pi r. The arc length is theta over 360, where theta is this angle. So if this were 45, so if my central angle here were 45 degrees, what would this arc length be? Well, it would be 45 degrees over the total of a circle, 360, because I'm just accounting for this little portion of it. So if this was 40 degrees, it would be 40 over 360, and then times my circumference, 2 pi r. We'll do some examples with these. And then we remember that a sector is a slice of pizza for my circle. This is my sector. It's just like a triangular pizza slice. How do you find the area of a sector of a circle? Well, that formula, we're going to do theta over 360 again, because this is just accounting for, this is just letting us know that we're taking just a piece of the circle. We're taking this ratio, this theta over 360, where that's theta. But anyway, the area of a sector, the formula is theta over 60 times the area of a circle. We remember the area of a circle is pi times the radius squared. Well, to find the area of a sector of the circle, it's going to be pi times r squared times this theta over 360. We'll do some examples.